Hello everyone, my name is Dr. Paripasitamboon. I am an instructor from Information Technology program, Faculty of Science and Technology, Nakhon Pathom Rajapat University. Today, we are going to learn the fundamentals of visual computer programming. Lesson 6, Programming an app to make decisions. In this lesson, we will learn how apps can make decisions, how to test conditions with if and else blocks, and how to program an either-or decision. Moreover, we will learn how to program conditions within condition and complex conditions in an app building by App Inventor. Let's get started. In the previous lesson, we discussed how an app's behavior is defined by a set of event handlers. Each event handler executes specific functions in response to a particular event. The response need not to be a linear sequence of functions. However, we can specify that some functions be performed only under certain conditions. For example, a game app might check if a player's score has reached 100. A location-aware app might ask if the phone is within the boundary of some building. Our app can ask us questions, and depending on the answer, proceed accordingly. In the diagram, when the event 1 occurs, activity A is performed. Then, a condition test is performed. If the test is true, activity B1 is performed, as shown on the left figure. If it is false, activity B1 is performed, as shown in the right figure. In either case, the rest of the event handler, activity C, is completed. Because app decision diagrams like this one look something like trees, we say that the app branches one way or the other depending on the test result. So, in this instance, we would say if the test is true, the branch containing B1 is performed. In this section, we will learn about conditional blocks. To test conditions, App Inventor provides an if-then conditional block in the control drawer. We can extend the block with as many else and else-if branches as we would like by clicking the blue icon as shown in the figure. Okay, to test conditions, we can plug any Boolean expression into the test sockets of the if and else-if blocks. A Boolean expression is a mathematical equation that returns a result of either true or false. The expression tests the value of properties and variables by using relational operators such as greater than and equal to, and logical operators such as and, or, and not, which shown in the figure. The blocks we put within the then socket of an if block will only be executed if the test is true. If the test is false, the app moves on to the ensuing blocks. For example, in a game, we might plug in a Boolean expression for checking a player's score. If the player's score is greater than 100, the app plays the sound. After that, the app jumps below the entire if-then block, and then moves on to the ensuing blocks. If we want a false test to trigger an action, we can use an else or else-if block. Next, we will learn how to program an either-or decision. Consider an app that we could use when we are bored. We press a button on our phone, and it calls a random person. In the figure, a random integer block is used to generate a random number, and then an if-else block calls a particular phone number based on that random number. In this example, random integer is called with argument 1 and 2, meaning that the returned random number will be 1 or 2 with equal likelihood. The variable random num stores a random number returned. After setting random num, the blocks compare it into the number 1 in the if test. If the value of random num is 1, the app takes the first branch, then, and the phone number is set to 081-111-1111. If the value is not 1, then the test is false, in which case the app takes the second branch, else, and the phone number is set to 082 222-2222. The app makes the phone call either way because the call to make phone calls is below the entire if-else block. Next, we will learn more about how to program conditions within conditions. In addition, many decision situations have more than just two outcomes from which to choose. For example, we might want to choose between more than two people in our random call program. To do this, we could place an else-if prior to the original else branch as demonstrated in the figure. With these blocks, if the first test is true, the app executes the first then two branch and calls the number 081-111-1111. If the first test is false, the else-if branch is executed, which immediately runs another test. So, if the first test, random num equal to 1, is false, and the second, random num equal to 2, is true, the second branch is executed, and 082-222-2222 is called. If both tests are false, else branch at the bottom is executed, and the third number 083-333-3333 is called. Note that this modification only works because the two parameters of the random integer call were changed to 3, so that 1, 2, or 3 is generated with equal likelihood. We can add many else-if branches as we like. We can also nest conditionals within conditionals. When conditional tests are placed within branches of another conditional test, we say they are nested. We can nest conditionals and other control constructs, such as for each loops to arbitrary levels in order to add complexity to our app. Let's move to the next section, programming complex conditions. Besides nesting conditionals, we can also specify single conditional tests that are more complex than a simple equality test. For example, consider an app that vibrates when our phone and presumably adds leave a building or some battery. Such an app might be used by a person on probation to warn him when he strays too far from his legal boundaries. Parents might use it to monitor their children's whereabouts. A teacher might use it to automatically take roll if all students have an Android phone. One last note on Boolean variables. Take a closer look at the two if tests in the figure. Are they equivalent? The answer is yes. The other difference is that the test on the right is actually the more sophisticated way of asking the question. The test on the left compares the value of the Boolean variable with true. If within battery contains true, we compare true to true, which is true. If the variable contains false, we compare false to true, which is false. However, just testing the value of within battery, as in the test on the right, gives the same result and is easier to code. This brings us to the last section. Finally, we'll take a look at the conclusion of this lesson. In conclusion, we learned how to build the decision-making logic, how to use if and else-if blocks to test conditions, and select what an app responds to result of the testing. And then, we learned nested condition. Conditional tests are placed within branches of another conditional test. In addition, we have learned how to specify more complex conditional tests by using relational and logical operators such as and, or, and not. This presentation is based on the book App Inventor 2, Create Your Own Android Apps 2nd edition by David Rober, Hal Eberson, Alan Spetus, and Liz Looney, O'Reilly Media Incorporation, USA, 2014. That's the end of this lesson. Thanks for watching.